Everybody, this is the rest of the 2019 Keystone multiple choice items that were released in order to prepare for this exam. I'm pretty sure I made another video for the first 12, the Module 1 items, and this would be for Module 2, which, as you hopefully by now realize, the test, we normally do a morning session and then an afternoon session. So two different sessions, and Module 1 is the morning session, and there obviously is at least a little bit of overlap, like certain concepts can appear on both modules, both the morning and the afternoon, but there's a lot of differences, right? Like there's basically a list of different concepts for Module 1 and a whole list of different concepts for Module 2 that are separate to a very large extent. So Module 2, and fun fact, yesterday I was doing this video. I was trying to make this video, and I got to like the 11th question or something, and my computer totally froze. So take two. Here we go again. Number 1 talks about how a graph of a relation is shown below. Okay, don't overthink the word relation. It is a fairly specific vocabulary word, but if for something to be a relation, all it needs to really do is involve x and y. So like any graph in the xy plane is basically a relation. Any equation involving x and y represents a relation. Any xy table of values represents a relation. All it takes is just to pretty much involve some kind of relationship between two variables, and those two variables are almost always x and y. So so there's a graph, and the question says, removing which line segment from the graph would make the relation a function of x? Function is another very specific vocabulary word, a little bit more important and more noteworthy, I would say. What is a function? What does it take for something to be a function? Well, if you looked it up in a textbook or on Wikipedia or something, it would probably say something like, for every x value, there can only be one y value, for every input, there's only one output, like in a function, if it's to be an actual function. Now, there's certain ways to tell, depending on if they show you a graph, if they show you a table. There's certain quick ways to tell if something's a function. When it comes to a graph, how do we tell if it's representing a function by way of, looking at a graph? Well, do you guys remember the vertical line test? That should ring a few bells. The vertical line test. The vertical line test says if you can draw a vertical line anywhere on your graph and only have those vertical lines hit the graph once, then it passes the test. Now, obviously, this at the beginning here fails the vertical line test miserably. If you draw a vertical line right there, it's hitting the graph right there and right there. So that's a fail. You draw a vertical line even out here, and it's hitting the graph in two different spots. So that's why the question is saying what it's saying. Removing which line segment from the graph would make this a function, would allow it to pass the vertical line test? Well, I mean, if you removed the left line segment, obviously it would still be failing. If you remove the right line segment, we would still have these two line segments, or even this one over here, right, where it would still fail. If you removed the top segment, you would still have this segment and this second vertical line I drew. You still have that to show that it would still fail. So it's this bottom line segment, okay? Which once you know about the vertical line test and you've realized how to figure this out, it's from there it's kind of just common sense that it's the bottom line segment. Because if you remove the bottom line segment, like just imagine removing that. I don't know how you can just use your imagination or what I just did. Now any vertical line you draw is only going to hit the graph in one spot. So notice how they're describing it with coordinates. So -4, -2, and 4, -3. That should be D. The set of ordered pairs below is a relation. Of course it is. X, Y, X, Y, X, Y, X, Y. Anything involving X and Y you can call a relation, representing a relation. Which relation has the same domain as the given relation? You definitely need to know that domain refers to the set of all x values or x coordinates or whatever. The set of all x's. So this given relation has a certain domain. It's just the list, the set of all the x's. Remember, this always goes xy, 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 xy. So it's 0.5, it's 1.5, it's 4.0, and it's 6.5. So which one of these relations, options, these choices, have the same domain? A pretty simple question, All you got to do is go through the choices, which is how a lot of multiple choice questions are designed. You really have no choice but to just go through the A, B, C, D choices to find the correct answer, or figure out which one's the answer. So let's see, 1.5. Oh, right there. That's a deal breaker. There's no domain of 2. 0.5, 1.5, 4.0. Aha, okay. B is looking very correct, but you should always at least give C and D a look, just in case. So 2, no, that's a deal breaker, and -1, oh, that's a deal breaker. So it is B. Next page. A teacher, hey, I'm a teacher, buys some pencils. Hey, I've bought pencils before. I wonder if this question's talking about me. A teacher buys some pencils. He buys 2 pencils for each of his students. He buys 10 additional pencils. Each pencil costs $0.10 or, 10 cents. Which equation describes the total amount of money Y? Okay. So it's, as I always say, I feel like I've said this 100 times. It's very, very important to, take note of what the variable represents. Like these Keystone questions, very much, the way they're designed, you need to pay attention to that kind of a detail to get these questions right. A lot of that on the Keystones. So which equation describes the total amount of money Y, so that's what Y is, that the teacher spends on pencils as a function of the number of students X. So X represents the number of students, and Y represents the total amount of money. So, okay, so again, Y, X is how many students. So, let's see here. So I don't think we're going to do 2 times x because we're not trying to figure out how many total pencils or something. Y is the total amount of money. So 2 pencils for each student, that means he spent 20 cents on every student. So I'm liking C right away. Now, of course, I'm not ready to full send that right now, but see how like 0.20x, because we're going to multiply how many students times 20 cents, because 2 pencils for every student, that means 20 cents spent on every student. But then, this teacher also bought 10 additional pencils. So again, we're not just going to add 10 because, again, Y is not the total pencils. Y is the total amount of money. So buying 10 additional pencils at 10 cents a pop, that's $1 additional dollar. So, yeah, I'm liking C. 1.2, no, we're not spending $1.20 on every student. See, this equation is saying that we're spending $1.20 on every student, and so we would multiply the number of students times 1.20, and that's going to get the total. No, we're not spending $2 on every student, right? Anyway, moving on. Number 4, the table below represents a function of x. That means for every x, there's only 1 y. That means there's no repeat x's. Like when it's a table you're looking at, you can tell that it's actually a function because there's no repeat x's. Anyway, that's not what this question's really all about. The question's asking which equation describes the function. I tell you what. Knowing how to make connections between tables and equations and graphs, man, that is key to the Keystones. See what I did there? So like whether it's matching an equation with a table or a graph with a table or an equation with a graph, like any type of direction there, like drawing a relationship, man, you got to be able to know how things connect. Tables, equations, and graphs. Oh my. So in this case, which one of these equations? Okay. Well, you notice how all of these are written like y equals mx plus b. Now, before I go into that a little bit further, you could theoretically just check whether each answer is the correct answer, because these are all like, okay, x is 4, y is 16. You'd have to be able to plug that combination into the correct equation to actually make it true. Like, okay, 16 for y, so 16 equals -2 times 4 plus 12. Does that actually equal? Like, does 16 actually equal -2 times 4 plus? Okay, so -2 times 4 is -8. -8 plus 12 is 4, not 16. So I already know if I continue with that strategy, I already know that A is not the right answer. Now, again, it's not just about 4 and 16 working. All of these pairs, 6 and 12, 8 and 8, 10 and 4, all of these pairs have to work with the correct equation. So you could do it that way. Or, you could try to figure out what's m, because again, y equals mx plus b. Now, as far as m goes, you really only need a couple of these pairs. They gave you 4. So you might have heard me say this at some point in class, or maybe you will hear me say this in class. When you have a table, they usually give you like about 4 pairs of... You only need 2. You only need 2. 4, 16, 6, 12. So remember, slope is the change in y divided by the change in x. So if I did 16 minus 12, the bottom has to be 4 minus 6. 16 minus 12, I believe, is 4. And so my overall slope, oh my gosh, is negative 2. You know what that means? That means I already know what the answer is going to be. Because if it's not A, it's B. But let's continue. Let's see this whole strategy out, okay? Now, what's B? You know, can we tell what B is from a table? Actually, you sort of can. All right? Remember, your y-intercept is B. And your y-intercept is always 0, something. So if you can somehow go in your table and figure out what 0 would match up with, like, 4, 16, 6, 12, 0 what? And here's what you can do. You can sort of like trace this back with like a pattern, like 10, 8, 6, 4. If you keep that pattern going in reverse, 2 and then 0. So what's the pattern? 4, 8, 2. Oh, that's a pattern. So that would be a 20. And with the 0 would be 24 for my B value, my y-intercept, 0, that. Your other option is to actually take your M value and take, maybe that point right there and plug into either y equals mx plus b, or like I emphasize in class, plugging into that. This is a third way to go about your business. Like again, you now know that m is negative 2. You have a random point of 4, 16. Could have chose any of these, but 4, 16. Y minus 16 equals negative 2 times x minus 4. And then you just kind of keep this going like we've done 100 times, and you would end up with y equals negative 2x plus 24. Number 5, Barry paid a total of $62 for 3 hours of driving lessons. Who needs driving lessons? This included a $20 fee for the driver's manual and an hourly rate, this usually means slope, for use of the car. What is the hourly rate? But I don't know if this one actually really, you need to kind of go like with the, it's slope. But keep in mind, rate definitely can mean or would have you thinking about slope a lot of the time. So $62 total. $20 of that was just for the stinking manual. So that leaves $42 left over, which is based off of like the 3 hours. So 3 hours costs $42. So all you got to do now is like divide that by 3 to get 14, I believe. Again, be careful about doing mental math. Have a calculator and go with that, But it's A, man. And yeah, like you could like reverse engineer this math very easily, but you could like literally write out sort of like a formula, like the total 62 would equal the $20 no matter what, plus 3 hours times whatever the hourly rate is. 3 times whatever that rate is, plus the 20, so now you can just like literally solve for x. But doing all your moves here that would like get x by itself, it's the same math steps we just did right here. Subtracting 20 from 62 and then divide. So the answer is A. Number 6, the graph below represents a linear function. Of course it does. It passes the vertical line test. But again, not what we're talking about here. Which equation describes the linear function? Okay. We'll see here. Okay. See, if you're somebody that, again, I'm going off on a little bit of a tangent here, so bear with me. If you're someone that, if you somehow are given or can figure out your slope and some point, you might have been taught to use this form to come up with the equation. Again, what you're given, what you know, is the slope of a line and then some random point. You may have been taught to and you may prefer this method of actually plugging that information into this and then going there. But I like to emphasize knowing about this formula for making an equation. Look at these choices. They are literally in this form. So you have to understand, well, you definitely got to know about this formula, but you also, going into the Keystones, need to know how this works. How, this part of your equation would be the slope. So, is our slope, look at this, 3/5. This is not even going to be like a deciding factor. All the choices say, so the slope is definitely 3/5, right? Look at this. Right there. I'll even verify that for you. 1, 2, 3, rise of 3, 1, 2, 3. Yeah. So our slope is definitely 3/5. That's not even up for debate, So now it's just a matter of okay, how do we also plug the point in for this formula? Well, again, the 3 goes in for x1. So there's a minus built in, and so that 3 goes there, and the y-coordinate of my point goes in for y1. And again, with a minus built in, so there we go. That's how the formula works. You have to understand what you're looking at when you see equations in this form. And so apparently it's D, right? Yeah. Just wanted to make sure. Number 7. Martha. Martha. What was that, what Batman? Batman's versus Superman? Why did you say that name? Martha earns money sewing curtains. She charges a flat fee. Man, this happens all the time on the Keystones. There's a flat fee and then some rate. So there's a flat fee just to take measurements. But there's also an hourly rate to sew the curtains. The graph below shows the relationship between the time in hours Martha works on a sewing project and the total amount in dollars. Okay. So for example, if she spent 4 hours on a job, she would be charging $60. What is the hourly rate? Okay, here, man, the word rate, absolutely you need to think of the word slope immediately. So rate is pretty much goes hand in hand with the slope. Okay? In other words, if we were to come up with the equation of this line, the slope of that line would represent the hourly rate. Heck, we could come up with even if we didn't have the graph of the line, we could sort of outline an equation at least. We could say, okay, so the total amount. So the total amount would be equal to, some flat fee plus her hourly rate times the number of hours. You know what I mean? Which, again, in this graph, I guess the number of hours would be X. And if I wanted to kind of put this in actual mx plus b form, I could rewrite this as y equals rx plus f. You know, the total amount of money equals the rate times the number of hours plus whatever the flat fee is. You know what I mean? So in this situation, the r, the slope, I should say, sorry, the slope is our rate. And by the way, little side note, the flat fee is actually our y-intercept. Like if they asked you a question, which they totally could, they say, look at this graph, you know, what is the flat fee, or what does the y-intercept represent? And you could look at that and go, oh, okay, it looks like 20 is that flat fee. It's literally the charge for 0 hours of work. So 20, the y-intercept, is the flat fee, okay? Anyway, in this question, we want to know about the hourly rate, so we want to know about the slope. So it looks like I have a lot of nice looking. So it looks like I would rise. Okay, people, if you're going from, say, this dot to this dot, are you rising 1 and going over 2? No. Look at this. You're going from 40 to 60. You're going up 20 over 2. So rise of 20, run of 2, and so that becomes $10. $20 for every 2 hours, that's $10 per hour. That's the hourly rate. Number 8, the ocho. Dodgeball reference, in case you think I'm just some weird Spanish person. The scatter plot below shows the relationship between the number of video files x, okay, well obviously the number of video files is my x variable, and the number of gigabytes is obviously my y variable. But what are they asking for here? Based on the scatter plot, which equation represents a line of best fit that could be used to predict the number of gigabytes of storage space available based on the... Okay, gang, all they want here is if there was a line of best fit, which might as well draw it or sketch it or whatever. Oh gosh. Piece of paper is a poor substitute for a ruler, but hey, that worked out decently, I guess. Remember, I don't think you're allowed to have a ruler on the test. I think for some reason rulers are banned at this point in time. But anyway, so all we really want to do is think about what is the equation of that line. So again, all of these are in mx plus b form. So the best case scenario is, can we just figure out quick what m is of this line and what b is, and then we have it, right? As far as b goes, I mean, that's the y-intercept. Oh my god, you got to know that. You got to know that b represents the y-intercept. So that's where it appears to be hitting the y-axis, but sometimes the y-axis is not really there. Let's see, so 8, 6. All right, now in this case, that actually is the y-axis. Like we didn't, like you don't see one of these jagged deals right here, right? Like we're not skipping anything. So yes, this actually is. So it appears, and we don't want to jump to conclusions, but it appears that 227 is looking pretty good. I mean, so that's looking pretty good, but I mean, like, you know, can you be sure about it? Let's see what m would be, right? I mean, look, obviously 116. There's no way. I mean, right? There's no way it can be. I mean, unless this is a horribly written and drawn question. There's no way it's 116, and I would go so far as to say there's no way that it's even 189. But let's investigate the slope, okay? Um, let's say we were talking about that point, which is looks like 1 comma 225. I'm going to go with that. And I don't know. Again, remember, the farther apart, the better. I guess I'll go with 16 comma 100. You know what I'm saying? Right? 16 comma. Let's see again. This is a non-exact type business we're in right now, but let's see what happens. So we have 100. Let's go the other way now. We'll go 100 minus 225, which means now we have to do 16 minus 1. So that's going to be negative 125, I believe. All right, I don't want to be a hypocrite. Mental math is, you just grab a calculator, right? Okay, I am correct. And then 16 minus 1 is 15. So when we do that division on my calculator, I get like negative 8.33. It's basically negative 8.3 repeating. So it looks like my slope is, well, my slope is obviously not negative 14. Okay, it's just more evidence, it's more assurance that the bestest answer has got to be C. Not only does it have the best looking B value, but it has the best looking slope value. I mean, the only other slope value that looks pretty good is negative 9, but there's no way 116. So C. I'm using that yellow mamma jamma, which perhaps you also are using, but number 9. A data set shows a basketball team's final scores for one season. Some information about the scores in the data set is listed below. Minimum value 42. Lower quartile. Remember, that's another name for like lower half median, the lower median. Well, the median is 60. The upper quartile, which is another term for like upper median, that's 72. And then the maximum, this is basically like, makes me think of a box and whisker plot, these specific items. Of course. Of the team's final scores for the season, 75% of them are most likely between... Okay. You got to remember, people, that... And again, totally makes me think of a box and whisker plot. Minimum 42. Lower quartile 54. The median is 60. So here's a little quick review of what a box and whisker plot sort of shows. Upper quartile, which would be 72. Anyway, please remember with percentages, the median, okay, it's literally the middle value, okay? It's going to cut the data in half, sometimes exactly in half, like literally 50% in half, where 50% of the data is below the median and 50% of the data is above. It's 50-50, 50%, you know? So from 60 to, so about or exactly 50% of the data falls between 60 and 90. And about or exactly 50% of the data is going to be between 42 and 60. But remember, we also have like these upper, like this upper median and this lower median. The upper median, for example, cuts the 50% in half. It's the median of just this 50%. So that means like with the 54 and this, now we have like these 25% chunks. Between 42 and 54, that's about or exactly 25% of your data. Here, between 54 and 60, another 25%. Between 60 and 72, another 25%. And between 72 and 90, another 25%. So 75%. Okay, 42 and 66. What? I'm not even going to entertain that for now. 42 and 72. Ooh, 25, 25. That looks very correct. But I'm not going to full send yet. Let's check out C and D. 60, no, that's only 25%, man. 70, that's only 25%. Man. Number 10. The owner of an ice cream stand conducts a random survey of 50 people to determine which ice cream flavor customers prefer to buy. The bar graph below shows the results. Okay, so according to the bar graph, it looks like, what do you think that is? Let's go with 18. If not 18, then 17, but let's go with 18. Mint chocolate chip, let's just go with 6. Pistachio, let's go with 5. Vanilla, let's go with 13. And then the other, let's go with 7? I don't know. Does this even add up to 50? Again, if these are at least close, right? We'll see. We'll see if that comes into play. The ice cream stand is expected to serve 350 customers on the first day of summer. Based on the results of the survey, which value is see? That's why they say most likely. I don't know, but most likely the number of customers who will buy an ice cream flavor other than chocolate. Okay. So we want to use the results of the 50 people to pretty much like upscale it and predict what the results would be. Because, you're expecting the same fraction, the same percentage of the 350 to like chocolate as the 50 people surveyed. So essentially, 18 out of the 50 liked chocolate. So you want that same fraction. So it's like, what number out of 350 would basically be 18 out of 50? It would be the same percentage, the same ratio, okay, the same fraction, whatever. So here we could actually cross multiply. This is a proportion after all, but I mean, like, you could sort of use a little maybe common sense. 50 times 7 would get 350. So 18 times 7, going to my handy dandy calculator. So whether you cross multiply or whatever you do, you should be able to figure out that we can expect 126 of these customers to pick chocolate. But the question is saying other than chocolate, right? Reading comprehension, people, and paying attention to the details and like reading very carefully. So what do we got to do? We just simply have to do 350 minus 126, which I will do on my calculator. And, I might not get exactly one of these options, but I'm So we got to, maybe we'll go with the best one, but we'll see. 350 minus 126 is that one. Hey, spot on. But even if you would have got like 220 or 225 or something, I don't know, or even like 230, you would have still picked D. You know what I mean? In a question like that. Final page. Jeez, finally. This is where my computer froze on me yesterday and I lost everything. Anywho. Number 11. A scatter plot shows the relationship between the distances. Okay. So the distances, that's x in miles. So x is the number of miles, essentially, from a local airport to airports in various cities, and the time y in minutes. So y is the number of minutes, x is the number of miles. And then they go on to give you an equation, which is always a good thing. So this equation might as well say, the number of minutes shall equal 0.16 times the number of miles plus 58.62. Talk about a precise equation. 50, oh my gosh. Based on the equation, which value is the most likely distance in miles between two airports when a flight between the airports takes 240 minutes? So they are giving you an equation that speaks of the relationship between x and y, or essentially speaks of the relationship between the number of miles and the number of minutes, and then they go on to give you a number of minutes. Number of minutes was the y variable. I'm just going to take this and literally replace y with the 240. I'm going to plug 240 in for y. Because if I have the equation, I can very easily figure out what the x value would be for that particular y value. And so now I just have to solve for x. Do I not? Calculator time. See, I'm assuming we're going to get like a decimal answer. And so that's why they say most likely, because they just have like these clean looking answers over here. So I'm going to assume, this is just literally a guess, I'm going to assume that x is not going to be exactly one of these, but it's going to be darn close. Anyway, calculator time. 240 minus 58.62. 240 minus 58. Okay, so that says 1, let me see. There we go. 181.38 equals 0.16x. And now it's time to divide both sides by 0.16, which I will also do on my calculator. And it's looking like it's 1133.625. So what's by far my best answer? 1133.114. Number 12. Finally, okay. There are 28 students whose last names begin with the letters G, H, J, or K. Information about the probability of randomly selecting one of these 28 students. Information about the probability is listed below. All right. So the probability of selecting a student whose last name begins with G is a 1 out of 7 shot. Probability of selecting a student whose last name begins with G or H, 5 out of a 14 shot. How many of these students have a last name that begins with H? First of all, I have this weird feeling that I've seen this problem before on one of the other multiple choice, you know, packets or whatever. Like maybe it was in 2018, maybe it was 2017. But I have a weird feeling that this is a repeat question. So anyway, so if there's 28 total, and if the probability of selecting someone whose it was a 1 out of 7, so like 1 out of 7 was like what out of 28? You know what I mean? Like what was the actual number of people with that last name out of 28 for it to basically be a 1 out of 7 shot? Wouldn't that have to be 4? Right? So 4 people. Okay? Now G or H, that's both of them combined. So 5 out of 14 would be like how many people out of the 28? Well, I mean, let's just let's cross multiply. So 5 times 28 equals 14x. 5 times 28 should be 140. Again, check your calculator if you're not absolutely positive of your mental math. And then dividing both sides by 14, I'm going to say 10, but I mean, like, again, don't want to be a hypocrite. I'll go to my calculator. 140 divided by 14, it's 10. Okay, so that means, listen, so that means the probability of getting, that means that there's 10 people that have a last name of G or H. So that the total combined G and H is 10. But if 4 of those were G, then H must be 6. So there must be 6 people whose last name begins with H, 4 people whose last name begins with G. And that's why, anyway. But that does it, huh? That